Look at your face in a mirror right now. You have something on it that no other animal on Earth has. Not a chimpanzee, not a gorilla, not a Neanderthal, not a single other primate that has ever lived on this planet. You have a chin, a proper, jutting, bony chin. And for over a century, scientists have had no convincing explanation for why. That small triangle of bone at the bottom of your jaw is one of the strangest features in all of human anatomy. It serves no obvious mechanical purpose. It does not make you stronger. It does not make you faster. It does not help you bite, chew, or speak. And yet, here it is, prominent, permanent, uniquely yours. The chin is a mystery wrapped in bone, and the deeper you go into what scientists have discovered about it, the stranger the answer becomes. To understand why the chin is so bizarre, you first have to understand what it is not. Most people assume the chin is just the front of the jaw, a structural feature, something that developed because jaws need a certain shape to function. But that assumption falls apart almost immediately when you compare a human skull to the skull of our closest living relatives. A chimpanzee jaw slopes backward from the teeth. The front of the jaw recedes. A gorilla does the same. A Neanderthal, who was bigger and stronger than you and had a larger brain case, also had no chin. The bone at the front of a Neanderthal jaw angled inward, just like every other primate. The chin, that outward protrusion below the teeth, simply did not exist. Then, roughly 100,000 years ago, something changed. Anatomically, modern humans began appearing in the fossil record, and with them came the chin, a new shape, a new feature, something evolution had never produced before in any member of the human family. Anthropologist James Pampush at Duke University has spent years trying to solve this problem. He tested nearly every existing explanation for the chin against the fossil and anatomical record. What he found was that almost every popular theory collapses under scrutiny. The oldest explanation is mechanical. People assume the chin evolved to strengthen the jaw, that the bone protrusion acted as a buttress against the stresses of chewing. It sounds reasonable, but the math does not support it. When you analyze where chewing forces actually travel through the jaw, the chin is in the wrong place to do any meaningful reinforcing. The bone is not oriented correctly to resist the dominant stresses. If evolution wanted to strengthen your jaw, it would have thickened different parts entirely. So the mechanical argument fails. The next theory was speech. The idea that the muscles involved in language needed a different anchor point, that the chin emerged to support the complex articulation required for human communication. Again, it sounds plausible. But no other species that communicates with complex sounds has developed a chin. Birds produce extraordinarily complex vocalizations without one, and the specific muscles involved in speech do not attach to the chin in any way that would require its presence. So the speech argument fails too. Then there is the idea that the chin is simply a byproduct, a spandrel, to use the technical term, something that emerged not because it was selected for, but because it was a side effect of other changes. The human face shrank significantly over the last 100,000 years. Our jaws got smaller, our teeth got smaller. Some researchers argued that as the upper jaw retracted, the lower jaw lagged behind slightly, and the chin is just what that lag looks like from the outside. But Pampush tested this theory as well. If the chin were simply a geometric side effect of jaw reduction, you would expect to see it appear proportionally in other primates with smaller faces. You do not. The chin is not a mathematical consequence of a smaller jaw. It is something distinct, something that has to be explained on its own terms. This is the point where the science gets genuinely strange. If the chin is not for chewing, not for speaking, not a structural accident, then what is it for? The answer that has emerged from the most recent research is one that says a great deal about what kind of animal you are. The chin may be a product of sexual selection. Anthropologist David Witter and a growing number of researchers have pointed to the pattern. Features that serve no clear mechanical function but appear prominently on the face, especially features that differ between males and females, are often shaped by mate choice. Human male chins tend to be larger and more pronounced than female chins. That dimorphism, that difference between sexes, is a classic fingerprint of sexual selection. Think about the peacock's tail. It is enormous. It makes the bird slower and more visible to predators. it serves no survival function. In fact, it actively reduces survival odds, but it persists because peahens prefer it. The cost is paid because the social reward is greater than the survival penalty. The human chin may operate on a similar logic. A prominent, well-defined chin signals something to other humans. Not consciously, not deliberately, but at some deep perceptual level, jaw shape is read as a cue to health, symmetry, hormonal status, and developmental history. Studies on facial attractiveness consistently show that chin shape influences perceived attractiveness in both sexes, though the preferred shape differs. Women with softer, rounder chins are rated as more attractive by many subjects. Men with more prominent, defined chins are often rated as more dominant and healthy. This is not a coincidence if you are looking for evidence of sexual selection. But here is where it gets more complicated, because sexual selection alone cannot explain why the chin appeared when it did, roughly 100,000 years ago, or why it appeared in all modern humans and not just in one group. Researcher Nathan Holton at the University of Iowa has offered a different angle. He argues that the chin is connected to a broader transformation in human biology around that period. The human face was not just getting smaller, it was getting less robust. The brow ridges were shrinking. The muscle attachments were becoming more delicate. The whole architecture of the skull was becoming more gracile, more refined. And Holton's research suggests this is linked to a drop in testosterone. Not a dramatic drop, a subtle, long-term reduction in the hormonal environment that shapes the developing skull. Lower testosterone during development produces a more gracile face, a smaller brow ridge, a less projecting jaw, and, crucially, a chin. The chin, in this model, is not an addition. It is what remains when everything around it reduces. As the upper jaw pulled back and the overall face became less testosterone-driven and more gracile, the lower margin of the jaw stayed in place. The chin is the part of the jaw that did not retreat. But why would testosterone levels drop across the human population? What was happening 100,000 years ago that would drive that kind of change? The answer may be civilization itself, or at least its earliest roots. Around the same period, something was shifting in human social behavior. The archaeological record shows a sudden bloom of symbolic thinking. Cave art, ochre used for decoration, trade networks spanning hundreds of kilometers, burial of the dead with objects, the beginnings of the cognitive and social infrastructure that would eventually become culture. And culture requires cooperation. It requires the ability to live in larger groups, to negotiate, to form alliances with strangers, to manage complex social hierarchies without constant physical conflict. High testosterone is associated with aggression, with status seeking through dominance, with behavior that fragments rather than coheres a group. A subtle, population-wide reduction in reactive aggression would have been enormously advantageous in a species that was beginning to depend on collective problem solving. It would have made larger groups more stable. It would have made trade possible. It would have made the sharing of knowledge across generations more viable. And as a byproduct of that hormonal shift, the face changed. The brow ridges softened, the jaw retracted, the chin emerged. This is the self-domestication hypothesis, developed most fully by anthropologist Brian Hare at Duke University. The idea is that humans essentially domesticated themselves the same way we domesticated dogs and other animals, by selecting for reduced aggression and increased social tolerance, and that the physical changes we see in the modern human skull are the signature of that selection. Look at what happened to dogs. Wolves have a specific skull shape. Dogs, descended from wolves but selected over thousands of years for tameness and social compatibility with humans, have skulls that are softer, more rounded, with less prominent brow ridges. Domestication changes the face. It changes the hormonal environment of development. It produces what biologists call a suite of domestication traits. Floppy ears in dogs, white patches of fur, curly tails, reduced skull robustness, neoteny, the retention of juvenile features into adulthood. In humans, the domestication suite may include the loss of heavy brow ridges, the reduction of the projecting jaw, and the emergence of the chin. You are, on this reading, an animal that selected itself for social compatibility, and the chin is the visible proof of that process. There is something quietly astonishing about that idea. Every time you look at another person's face and read their expression, every time you make eye contact and feel something about who they are, you are using a social perceptual system of extraordinary sensitivity.